Hello everyone, welcome to our chemistry channel ChemPhilic. In the previous video, we have discussed some MCQ type question and assertion reason based on this chapter. Matter is nature and behavior. Link is given in the description box, so please go through it. Today, we will do some case-based study type question on this chapter. So, let's get started. So here, this is the first question. As you can see that three pictures are there. This one is the ice cream, this one is the jelly over the bread, and this is the smoke. Okay, so the question is identify the types of colloid. Now, what are the types of colloid? For this, you have to know one small table, and this one is the table for you. Now here, in the heading, what is given? Dispersed phase, that means which is present in small excess. Next, dispersing medium. So the dispersing medium is present in large amount. Now what is the type of this colloid? And last one is the example. So dispersing medium which is present in large amount. So what are the states of matter? Three states of matter is there. One is gaseous, then is liquid, and after that it is solid. So in the dispersing medium, what we will write? We will write two gas. Okay, gas. In the liquid, okay, liquid is another state of matter. So three types of that means three liquid you will write liquid, and another one is the solid. Again three you will write solid. So the dispersing medium is present in huge amount. Okay, so two gases, two liquids, and three solids. 2, 3, 3 in this order. You can make this table by your own also. Now how? I am going to discuss that only. Okay, so in the dispersing medium you will write two gases, three liquids, and three solids. And in the dispersed phase, that means which is present in small number, what you will write? You will first write liquid, then solid. Gas. This we will not consider, because you know that gas particles will obviously homogeneously mix with another gas particle due to diffusion. So it will form a homogeneous mixture or a true solution. This will not form any colloid. That is why we are not mentioning gas. Okay, so dispersing medium is gas and dispersed phase is one is liquid, then is solid. And for liquid, what you will write? Gas, liquid, solid. And for solid also, for solid dispersing medium, the dispersed phase will be gas, liquid, solid. Now, what is the type or what is the categorization of this dispersed phase and dispersing medium? So, this is very easy thing. Okay, you can make it by your own. Now, how? What I have told, that dispersing medium, this is present in large number. So whenever the dispersing medium is gas, no need to think anything. You will just write the type as aerosol. Okay, when the dispersing medium is gas, you will just write the type as aerosol. Okay, whatever the dispersed phase is liquid or solid, both will be the aerosol. Now the next one, the dispersing medium is either liquid or solid. Okay, and the dispersed phase is gaseous. Okay, the dispersing medium is different. One is liquid, another one is solid. But the dispersed phase here is the same, gaseous. Then what you will write? The type will be the foam only. In both cases it will be foam. Now the next one, when the dispersing medium is either solid, liquid or solid. Okay, but the dispersed phase is the same. Both are solid. Okay, dispersing medium is liquid and solid, but the dispersed phase is same, that is solid. So it will be the sol. In both cases this will be the sol. And why it is written solid sol? Because here both the dispersed phase and the dispersing medium is solid. That is why this is written solid sol. Actually this is nothing but sol only. So what just you have to remember? You have to remember two things, that when the dispersing medium is liquid and dispersed phase is also liquid, this is known as emulsion. Okay, and when the dispersing medium is solid and the dispersed phase is liquid, this is known as the gel. Just these two you have to remember. Okay. And this other type you can do it by your own by just following this trick. Okay, now what are some examples? The examples of aerosol, liquid gas aerosol. So example is fog, cloud and mist. Solid gas, again it will form aerosol. Example is smoke and automobile exhaust. Now gas liquid, what it will form? It will form a foam. Shaving cream is a very good example. Next, liquid, it will form emulsion. So milk and face creams. Now solid liquid, it will form salt, milk of magnesia and mud. Gas liquid, it will form foam and sponge are the examples. Now liquid solid, it will form gel, so jelly, butter and cheese. Last one is the solid, it will form solid salt. Example, milky glass and colored gemstones. Okay, so here what is given? Ice cream is given. Okay, so ice cream, just try to find out that where ice cream is written. Yes, this is emulsion. Okay, liquid, emulsion. So ice cream, this is the emulsion. Okay, and in emulsion, as you know that the dispersed phase is liquid and the dispersing medium is also liquid. So this is a liquid type colloid. Now the next one, this is jelly. So here this is jelly, this is gel. Okay, jelly, gel, and dispersed phase is liquid, dispersing medium is solid. So this jelly, this is the gel. Okay, and liquid, solid, gel, and the last one is the smoke. Okay, so here it is the smoke. So this is aerosol, solid gas, and it will form aerosol. Okay, so it will form the aerosol, solid plus gas. Now move to the next question. Okay, not only these examples, okay, any example from this list may come in your exam. So now move to the next question. What is the next question? Okay. So here what you can observe, this is question number 2. Here you can clearly observe that light is passing, light is coming from this window in a dark room, and here these are the path or track of the light and which is clearly visible to us. Okay, and all the dust particles are also visible to us when light comes in a dark room. And here what you can see, here also you can see that one flashlight is there. So what is A? A is the salt solution, and B, what is B? B is the milk. So in salt solution, this salt solution, you cannot observe the path or track of the light. But in this milk, that means solution number B, you can see the path or track of the light. Now the reason is same. Okay, that why this is so. This is nothing but the Tyndall effect. Okay, this is due to the Tyndall effect. Now, do you know that what Tyndall effect is? Tyndall effect is the scattering of light. Tyndall effect is the scattering of light particles. Okay, now the colloids will only show the Tyndall effect, not the true solution. Now why? So suppose here I am taking one glass, and in this glass we are taking some salt. Okay, so salt particle will be soluble in water, and salt particles, they are very small in size. So if we pass one light, then what will happen? That these light particles, they will not encounter or they will not face any kind of collision with these salt particles. Okay, because they are very small in size. That means they will not scatter or they will not distract from their path. Okay, but you know that colloids, the colloids particles are larger in size as compared to the true solution. So these are the particles of colloids, suppose, somehow bigger in size as compared to the true solution. So whenever light is going to pass through this colloidal solution, then what will happen? Then this bigger size colloidal particle, they will hinder the path of the light. That means light now have to distract from its path. Okay, and here in this region you can show the path or track of the light. Clear? So here the dust particles, okay, in this room dust particles are there. So the dust particles, this will actually act as the colloidal particles, okay. And here the milk, the solution B is milk, and you know that in milk some insoluble fats are present which act as the colloidal particles, okay. So here in the milk you can show or you can see the Tyndall effect or the path of the track, path of the light, okay. And here this is the case with this sunlight also in the dark room, as because here dust and here the insoluble fat particles will act as the colloidal particles, and only colloid can show the Tyndall effect, that means scattering of light. Now let us move to the next question. So here this one is the next question, that this diagram will be given and you can see that some arrows are also given. So what you have to do, you have to write that what this is the aperture setup for distillation process, you know. Okay, an arrow is given, so you have to write that what is this. Okay, is this the Bunsen burner, the conical flux, the thermometer? These things you have to just write, okay. So what is this? The first one, this is the thermometer. Okay, so the first one here is the thermometer. Now what is the next one? As you can see, the next one is the distillation flux, because in distillation one flux is required, and in the flux only we will take the two types of that means we will take either one solid liquid or a liquid mixture, okay. So this one is the distillation flux. Now what is the next one? This one is the clamp, okay. What is the action of this clamp, or what is the utility of the clamp? Clamp will just hold the whole apertures, okay. Now what is this one? This one are, as you can see, the some vapors are producing here. So these are the vapor. Now what is this? Here obviously this is the mixture, okay, either a solid liquid or a liquid mixture. So here this is the liquid mixture. Now the next one, what is this? This is the, yes, Bunsen burner. So this is the Bunsen burner, because we have to heat the mixture, okay. We have to heat the mixture in distillation, you know, because when we can apply the distillation technique, when the boiling point of the two mixtures, these are of the components of the mixture, these are distinguishable enough, okay. So how it will go to the vapor state from its liquid state? We have to heat it, that is why Bunsen burner is required. And what is this? This is the stand, okay, to hold the whole apertures. Stand with clamp. Now when I heat the mixture, either it is solid liquid or liquid mixture, when we heat it, what will happen? Vapor will produce, the liquid will turn into its vapor state, so some vapor will produce. Now the vapor will come in this part, okay. So what is this? In this part it will again be condensed, because we can't collect the vapor state, okay. The vapor we can't collect, so we have to again convert it into liquid state. So how to convert the vapor to liquid? This is so known as vapor to liquid. This is known as the condensation process. That is why one condenser is required, and this one is the condenser. In this part, the vapor that are coming from this distillation flux will again be condensed to its liquid state. This is the condenser. Okay, and what is this? Two pipes are there. So through this pipe, these are the water inlets. Okay, and this one is the water outlet. That means through this pipe water will enter in this condenser to make it cool. Okay, and through this pipe water will out of the condenser. Now what is this one? This one is the liquid drops, because vapors will coming from this distillation flux. Now in the condenser, as it is cool part, so what will happen, the vapor state will again be condensed or again turn into the liquid state. So these are the liquid drops. Okay, and this is the receiving flux. Why receiving flux? Because we will collect the distillate water, okay, or the distillate into this flux. Okay, we will receive this. That is why receiving flux. And the last one, what is this one? This is the distilled liquid. Understand? So this is the whole aperture setup, and these are the names of this aperture setting for distillation process. So hope you have enjoyed the class, and if you think that this is helpful, then please like, share and subscribe.